Welcome everybody to Contemporary Math Lesson 2A Notes. In this section we will be working with units. And not only that, we are going to be reviewing a lot of fraction stuff going on here. Alright, so to be successful with this unit, you have to be understanding fractions and how they combine when you are adding, subtracting, multiplying, or dividing. It is generally regarded that multiplying and dividing are the easiest ways to start out with fractions. So just a very quick review on multiplying and dividing fractions before we get to adding and subtracting. So first we will talk about multiplication. You're more than welcome to type these in. I will not have these linked in the description. And I hope that they are still available to you, but feel free to watch these videos in addition to watching this one. First thing you want to do is when you're multiplying fractions, you'll notice that we can just multiply the numerators together and multiply the denominators together and make one big fraction. So a couple examples over here on the right. We have this fraction 1/3 multiplied to 2/5, so we can take the 1 and the 2 in the numerator and multiply them. We can take the 3 and 5s in the denominators and multiply them and put them in one big fraction. And we can multiply. 1 times 2 is 2, 3 times 5 is 15. That does not reduce, so we're good to go. The second example down here. We have 3/4 times 5/3. If we multiply 3 times 5 in the numerator and 4 times 3 in the denominator, you can see that the numerator and denominator both have a factor of 3. And since they have the same factor, we can reduce them. And so that's what those red slashes are there going through it, leaving us with just a 5 in the numerator and a 4 in the denominator is 5/4. All right. Moving on to dividing. Dividing fractions. What's happening here is that you can see we have a fraction a over b and a fraction c over d. But instead of multiplying now, it's dividing. So what we do is we take this second fraction and reciprocate it, aka flip it. Then when we do that, you can see a over b stays the same. But when we reciprocate that second fraction, the operation changes from division to multiplication. So we have a times d on the top and b times c in the bottom. Multiplication, we just talked about that up here. So in the example over here, we will take 2/5 and reciprocate it to 5 over 2, and we can multiply straight across the top. 3 times 5 is 15, 4 times 2 is 8. So there's the answer for that one. For addition and subtraction, we have a note here. You can only add or subtract or combine two fractions if they have a common denominator. So when you take a look at these two examples here, you'll notice the denominators are exactly the same. And we just get to add the numerators together and put it over one denominator. Same thing with subtraction. Instead of adding, it's subtracting. So you can see the example here, 1/5 plus 2/5. We can add the 1 and the 2 in the numerator, put it over 1/5, not 10. We do not add the denominators, and we get 3/5 over here because 1 plus 2 is 3. Now, for this next example 5, we have to do a little bit of work here. We have to multiply this first fraction top and bottom by 3 because that is this denominator over here. And we multiply this second fraction top and bottom by 2 because that is the denominator over here. When we do that, we will end up with 3 over 6 plus 2 over 6. And now the denominators are the same, so we can just add the numerators together. 3 plus 2 is 5 over 6. So looking at these, I want you to pause the video real quick, try these, and then I'll get the solutions going here in a couple seconds. All right, in the rest of these examples here, I'm going to start out with the multiplying and dividing first because those are generally going to be easier than the addition and subtraction. So I'm going to start here with example C, and what I'm going to do is write out the multiplication of the numerator and the denominator. And it doesn't look like I can simplify anything here. I can't simplify a 5 with a 3 or with a 9 or a 2 with a 9 or a 3. So I'm just going to go ahead and multiply straight across and get myself a 10 over 27. And that's it. Since we couldn't simplify anything here, we can't simplify our final answer. Let's see, more multiplication. Let's look at example E. So for example E, I'm going to rewrite it. So I'm going to rewrite it here. 6 times 5 over 25 times 6. And just like I did in the multiplication example up there, I'm just going to circle these real quick. I've got a 6 in the top and a 6 in the bottom. I'm going to cancel those right away. Why not? That works. We can get 5 over 25 then. Then we talked very, very briefly about simplifying a fraction up at the top there. We go over more of that in the next slide, simplifying fractions. But for right now, I know that the numerator and the denominator can both be divided by 5, so do it. That leaves you with 1 over 5. Awesome. All right. Let's see, let's look at example H. That's another multiplication example. So here we have 6 times 2/3, and you might be wondering, well, that doesn't make any sense. We're supposed to be multiplying fractions. All right, you can turn any whole number into a fraction by putting it over 1. So that will leave us with 6 times 2 in the top over 1 times 3 in the bottom. Now this is interesting. We have a cancellation or a simplification we can make right now. Even though 6 is not the same number as 3, we can still reduce those. 6 divided by 3, 1 in the top, 1 in the bottom, leaves me with a 2 in the top and a 1 in the bottom if you divide them both by 3. So in the top now we have 2 times 2, and in the bottom we've got 1 times 1. So 2 times 2 in the top is 4, divided by 1 times 1 in the bottom is 1. Let's see, this will be 4 over 1, but we don't want to leave a fraction over 1. You never do that. You just report back the top number, which in this case will be 4. All right, let's see. I see a couple of dividing examples, so let's do F next, and we'll go up here to D afterward. So remember, we take the second fraction and we reciprocate it. So this will be 4/5 times 25 over 8. And I'm actually going to take the time to write this out as a single fraction down here very quickly, because I think we can do some more canceling like we did in the last example there. So I'm going to look at the 4 and the 8. If I divide each of those by 4, I'll be left with a 1 up here and a 2 down here. But also the 25 and the 5. If I divide both of those by 5, I'll be left with a 5 up here and a 1 down here. So my overall fraction then becomes 1 times 5 over 1 times 2, which is just 5 over 2. Not that bad. For example D, it's done very similarly. I'm going to go through it relatively quickly here. Here's the solution for part D. We reciprocate the second fraction. We write it as one fraction. 2 will not simplify with 3 or 7 in the bottom. 8 will not simplify with 3 or 7 in the bottom. So we just multiply straight across to get 16 over 21. Lastly, the addition and subtraction exercises. And then I'm just going to go over how to find an LCD because the actual addition or subtraction is very simple after that. So remember what we did over here was I multiplied the first fraction by the denominator of the second fraction. So I'm going to multiply 3 and 3. And then I multiplied the second fraction by the denominator of the first fraction. So times 8 times 8. So what that leaves me with is 3, if I multiply those, over 24. 3 over 24 plus 16 over 24. And now, since we have the same denominator, we can just add straight across the top and get 19 over 24. Now, one thing that you'll want to do is you'll want to make sure that every single answer is in lowest terms or simplified. Lowest terms and simplified mean the same thing here. Like in the next example, if I take 6 from this first fraction and multiply it to the top and the bottom here, and 18 and multiply it to the top and bottom here, I'll get this. I'll get 42 over 108 minus 18 over 108, which can be reduced after we subtract these two fractions. That is 24 over 108. But this fraction is not simplified as best it could be. So what we can do is we can start dividing by numbers and see what happens here. So I can divide the top and bottom by 4, I know that much. So that'll give me 24 divided by 4 would be 6, and 108 divided by 4 would give me 27. Am I done simplifying? Well, we can divide 6 by 2. Can you divide 27 by 2? No. You can divide 6 by 3. Oh yeah, 27 can be divided by 3. So let's divide them both by 3 and we'll get 2 over 9. And I think we're done simplifying there. If you already understand how least common denominators work, then you're more than welcome to use that. It makes these problems a ton easier. And I will flash up a solution for part G down here because I'm going really lengthy on this video already. Here's the solution. See if you can talk your way through this. On this slide, we will be converting between decimals and fractions. And I'm going to make a liar of myself. All those links on the first slide and these links right here, I will make available in the description. So just go down there and look at those. Click on them if you want to see extra videos in this. So I'll just go ahead and continue. Decimals to fractions. So if we're going to convert decimals to fractions, we need to be able to recognize the value of the last digit in the decimals. So that is being able to identify whether you are working with tenths or hundredths or thousandths. And it's just 1 decimal place for tenths, 2 decimal places for hundredths, or 3 decimal places for thousandths. So for example, these 3 fractions right here, we would say each of them like this. We would have 4 tenths, 97 thousandths because it's out to the 3rd decimal place, or 25 hundredths because it's out to the 2nd decimal place. And so these fractions start making a little bit of sense. 4 tenths, whatever unit we use, tenth or hundredth or thousandths, that's the number that goes in the bottom. So 4 tenths. 25 hundredths, you notice there's 100 down here, 97 thousandths, there is 1,000 in the denominator. Now, these fractions are not as reduced as they can be, or at least not all of them anyway. we can simplify some fractions by finding a number that we can evenly divide into the top and bottom. So you can see we can do 2 and 2. So we can divide 4 by 2 and 10 by 2 and get 2/5 after that. And it is important to recognize when you can simplify a fraction and then actually simplifying the fraction. So for the case over here, 25 hundredths, we can divide each of these by 25. So if you do that, you'll end up with 1/4. Right? I mean, you guys can you've worked with money. Quarters are 0.25 of a dollar, so 1/4, 1/4, 0.25. I think that makes sense. But let's say really quickly you don't see that. 25 over 100. Let's just say, oh, I know I can divide both of these by 5 and get 5 over 20. You have to keep checking. So we haven't run into a scenario like this over here or over here yet. But if you find a number that you can divide into both the numerator and denominator, after you do it, check, is there another number I can divide into 5 and 20? In this case, yeah, we can divide another 5. So if I divide by 5, I'll get 1/4, just like we got. Can you divide 1 and 4 by some number? In this case, no. That's as simple as it gets, so that will be our answer. And similarly with 97 over 1000, that's it. That one will not simplify. So pause the video, go ahead and try these three. Turn these into fractions using their respective denominator, either 10, 100, or 1000, and then see if you can simplify it down. All right, so here are the fractions for each of them with the tenths, hundredths, and thousandths denominators. There you go. Now we have to just go through and see, can we divide these fractions, the numerator and denominator of these fractions, by something to simplify it? And yes, at least for the first two. The last one we cannot, because we only have a 1 in the numerator, so that will be as simple as it gets. The other two we can simplify. You can simplify in one step if you divide the top and bottom by 4 here to get 3 over 25. And you can divide in one step here if you divide top and bottom by 2, leaving you with 13 over 500. The next little section down here, converting from fractions to decimals, you really have to do is grab a calculator, to be honest, and you can just type these right into the calculator. So one thing that you'll want to keep track of is decimal places. So you want to make sure that you will be rounding to the correct decimal place. For example, in our practice here, round to the nearest hundredth. And I'm just going to give one away right up front. Spoiler alert, if you divide 2 over 5, like we saw up above, 2 over 5 turns into 0.4. Now it says round to the nearest hundredth when necessary. Well, 0.4 doesn't even get out to the hundredths place. It just goes out to the tenths place. So we don't have to worry about rounding. But if you type in your calculator 3 divided by 16, you'll end up with 0.1875. And hundredths place is 2 places. So we're looking at this right here. We want 2 decimal places. So the rounding rule is if the next number is 5 or higher, 5, 6, 7, 8, 9, we round this digit up. But if it's lower than 5, we will leave this digit the same. So it'll be 0.19. That's our final answer. because this next digit is bigger than 5. Go ahead and try the other two, and I'll be back in a few seconds. For these other two, when you divide 4 over 11, you get 0.363636 repeating. But we're only looking for these first two decimal places. Since this number is less than 5, we will not round up. We will leave everything the same in the 0.36. For the last example here, we have 7 divided by 24, which is 29166. And I'm guessing the 6's go on forever after that. But again, we're looking for the first two decimal places, and since this number next decimal place is less than 5, we do not round up. 0.29 will be the answer. This will conclude the first half of the lesson for section 2A. It's a bit of a lengthy lesson. I know videos can get kind of long nowadays for myself, so I'm going to stop it there. Good luck.